Hello everybody, this is Jeff Haber of Boeing Commercial Airplanes, and first thing, I want to thank you for joining us today. We're here in the Boeing factory in beautiful Everett, Washington. You're going to be really glad you did. This is the next step in the journey we've been taking together to give you some behind-the-scenes looks at how we're creating the magnificent 777X airplane family. And this is a really exciting day, because today is the day we're going to show you the very, very first completed 777X. It's an airplane that's not going to fly. It's a static airplane for test. We're going to talk all about that today. But this is going to be your chance to see the first completed 777X. And now I know you're already tired of looking at me, so let's take a look at the airplane. So there it is, completed. This is called the static test airplane here in the factory. By the way, you can also see the volume of this factory. Remember, it's the world's biggest building by volume, the WBBBV. And not only can you see the static test airplane, which we're going to talk about today, but if you look over to my left, your right, you'll see WH-001. That airplane, WH-001, is going to be the first airplane that's going to fly. I'm just giving it a minute to sink in. Totally cool. I know that those of you that tune in to this broadcast, you're airplane people, and what could be more exciting to aviation and airplane people than seeing the very first 777X? So, luckily, I'm not just going to stand here the whole time. We're going to go on a tour of the static test airplane from nose to tail. We're going to go all 252 feet, 77 meters of fuselage, and we're going to show you the whole 235 feet, 72 meters of the wing, the beautiful wing, which we're going to go to in some detail. So, first of all, let's get going. So the three things I really want you to get out of this broadcast today, number one is that this airplane is big. This is a big, beautiful airplane. Number two that we want to talk about is the technology that we've used on 777X, both in manufacturing and inside the airplane. And number three, when you finish watching this broadcast, I want you to say, that's a cool airplane, because it really is. So let's move a little bit closer. Let's go over and take a look at the flight deck. There's the flight deck. We talked a bit about the technology, and we said many times that the 777X is going to be the best of the 777 and the best of the 87 and some new technology. Those of you that may have seen a previous broadcast with myself and Van Cheney got to see us fly it. He really flew the thing. I didn't really fly it. Got to see the 777X flying, and you saw some of the great features. There's things you can see, like the 787 flight controls, but as you may remember from that broadcast, the 777X will be the first airplane, commercial transport, with touchscreen technology. Now, for those of you that have smartphones, which is almost all of you, touchscreen technology is probably not big of a deal. But in commercial aviation, this is the first. It's going to be awesome. So that's the flight deck. And when you get up close to it, you can see the size of the airplane, and this is where the pilots are going to, the 777X pilots are going to command this airplane. You're going to command WH-001 when it flies. So let's go a little bit further back along the fuselage. Here's access for the working crew. Here's the main section of the fuselage. This is section 43. We actually did a broadcast showing how section 43, the section right behind the nose section, is put together. And it's a little hard to see, but I want to talk a bit about some of the technology that's going to make this great for passengers. And one of the things that's going to make it great for passengers are the new windows. The windows on 777X are going to be, you can see one there, you can't really see it that well. They're going to be higher and bigger than previously on the 777 and on the competition. They're going to be 30% bigger than the competition. Well, what does that mean, 30%? I don't know what that means. Well, I just happen to have a little handy help here. Here's the 777X window, actual size, and here is the, well, I don't want to put it this way. Here's the competition. So you can see this is what 30% really means. So as we head back towards the wing section of the airplane, I always want to take this. Thank you very much. Always want to take this opportunity to thank our customers. Remember, the 777X was launched in 2013 at the Dubai Air Show. We have orders from a large customer base, and soon we're going to have many more. Our customers include, always give a shout out to the customers, ANA, Cathay, Emirates, Etihad, Lufthansa, Qatar, and Singapore. We love our customers, and we're going to have plenty more. So we're headed back now. This is totally cool. We're headed back towards the part of the airplane where the wing is joined to the fuselage, and I just wish we had somebody here that could give us some information about this static test airplane. Oh wait, there's somebody over there. She looks like someone who knows all about the static test airplane. I'm just kidding. We knew she was here. This is Doreen Bingo. She's the test lead on the static test airplane. Hi, Doreen.
Good morning.
So tell us a little bit. People always want to know about the people at Boeing. They want to know what's going on. So could you tell us a little bit about your history at Boeing, how long you've been with the company, exactly what your job is, and stuff like that?
Happy to. So I've been with the company for 21 years. All my years here have been in test. I'm currently the test leader for this program, which is really exciting because we've been in test for several years now for this different components of this airplane, starting with wind tunnels into smaller component structure, systems integrations lab. You've been there at airplane zero and ECAP, and this static test really represents the home stretch of our test program as we build these full-scale articles for both lab and flight tests.
So the total, tell us about the total number of airplanes that are going to be used for tests and where this fits into that overall scheme.
Sure. So static test is the first off the line, and we'll go into some details later. Then we have 4 flight test airplanes that are being built one after the other, and then the 6th airplane off the line is for our fatigue testing related to structures testing as well.
So could you tell us a little bit more about how you conduct the structures test, what kind of equipment is used, and maybe you could point some of the equipment out as we talk about the testing.
Sure. So static test is our opportunity to verify the structure, all the load-bearing parts of this structure, the airframe, the wings in particular. We will run it into our test site, and we'll have a reaction structure. We have a reaction structure built right there, 1.6 million pounds of steel, ready to receive this test article, and really the intention is to test the structural strength of the airframe, and so we'll run conditions on the wings. We'll run conditions on the strut, as you see right there, and the fuselage.
So when will this airplane fly? It's kind of a loaded question.
Well, we know this airplane will not fly. As you can see, it's nearly complete. We will not have real engines on this airplane. We don't actually install systems either because they're not load-bearing components. We really focus on building this aircraft for all of just structure and loads.
Okay. Hey, I hope you folks have some time because now we're going to walk along the wing. And because the wing is so long and beautiful, it may take a while. So sit down if you're standing. Here we go. Let's head outboard on the left wing. A couple of things. The wing, as you know from a previous broadcast, the skins and the spars are made out of composite right here at the Composite Wing Center in Everett. It's a long, slender wing. It has the highest lift-over drag ratio of any wing that Boeing's ever built. It contributes immensely, along with the engines, to the fuel efficiency of the airplane. Our airplane will be 12% more fuel efficient than the competition, which is great for airlines. And remember, this airplane is not going to fly. And so I was talking to Doreen earlier, and I wanted her to point out some of the equipment that makes this airplane, some of the test equipment that we use just on the static airplane. It's going to be up on the lower wing surface. Yeah,
so one of the questions we get is, how do you emulate loads on an airplane when you're not flying? So if you were to look at all of the different hardware, particularly the orange hardware, because that is very representative of non-production hardware, it's test hardware. It allows us to attach load to the wing and distribute the load in a way that emulates air loads, right? You can't have point loads, so this is what helps us essentially pretend like we're flying on the ground.
So I'm going to want you to tell everybody what happens at the wingtip when we do the test of the wingtip. But before we do a test of the wingtip, I thought, hey, let's go to the wingtip. So let's head back to the wingtip. We're going out. We're walking. Remember, we're looking at a 72-meter wingspan. and we're almost at the wing tip. And Eric Sven, are you getting a shot of the wingtip up there? And so, Doreen, tell us now. You can see the wingtip. We're going to talk about the wingtip tip in a minute. But Doreen, tell us about what happens when we test the wing.
Well, really, this wingtip, this is our folding wingtip. All it is the structural piece of it. Because again, load bearing, we have other tests that show it folding up and down. So that's where we do the systems integration. This is really just about the structure. So it's a part of just the whole wing when we test the structure for static.
So when you test the wing, you apply load to it, and what are the types of deflections? Like how far is this wing going to bend when you test it?
I don't know if they've finished the calculation on it, but certainly on 777, 26.5 feet at ultimate loads, which is 1.5 times limit load.
26.5 feet deflection of that wingtip?
These are large wings, so we do expect a higher deflection of that. And composite wings tend to be very flexy. Yeah.
Wow. So Eric, can you get a shot of that wingtip again? So there it is. There's the folding wingtip. You've heard a lot about it. The purpose of it is so that the 777X will be able to fit into 777 gates at airports. And I first saw this wingtip attached to the wing a few days ago. And when I came and I looked at it the very first time, what I said to myself was, is that it? Because it's 11.5 or 12 feet out of a 23 or 24 feet out of a 235-foot wing. So it's a really small part of the wing. As Doreen said, it's part of the structure. It's a really simple fold mechanism. And it's going to make our airplane, the 777X, even more valuable for airlines and for you because it increases the number of gates that it can land at. It can now land at, with this folding wingtip, it'll land at 777 gates. So that's the wing. Eric, could you get a shot of the wing from inboard to outboard? You'll notice also those blue wing crawlers. That's part of the new manufacturing techniques that we're using here on 777X to reinvent the way we manufacture airplanes. Last thing, we were gonna go walk to the tail, but the airplane is so long and beautiful that we've just run out of time. So Eric, when you finish looking at the wing, could you give us a shot of a picture of there's the tail, and Doreen, when you look at the tail, we don't need a vertical tail on a test airplane. But what's that orange that orange mechanism that we can see coming out of the fuselage?
That's what we call our dummy horizontal stabilizer. We don't actually need to test that portion of the airplane because it's verified other ways, but we need to represent the weight. So we do the cheapest method possible of building something that represents weight.
Doreen, you're like totally awesome. Thanks very much. Eric? Come on back, Eric. He's way over at the tail. It's a long way from here. So this is the static test airplane for 777X, airplane number 1. Remember, we're going to test the airplane in 2019. The airplane's going to deliver in 2020 to our wonderful customers. And I wanted to let you know that you can always go to www.boeing.com to the Reveal portal to get more information, to sign up for email updates for the airplane. And I want to thank you. I hope that this trip around the airplane was worth it. I thought it was awesome to get this close to a 777X, and it's a perfect example of the way Boeing is continuing to build the future of flight. We'll be doing more broadcasts as we go, as the airplane gets more and more mature. Remember, we started with just a wing spar, and now we have a whole airplane. So this is Jeff Haber from Boeing Commercial Airplanes. It's been a pleasure. See you next time.